Morning 102% here. We, batch 5 of Electronics and Communication Department, are here with our PowerPoint presentation on the topic Wearable Hand Tracker for CAD Modeling. Our team members are Kirtinamal CS, Ron Francis, Sebin Jos, and myself, Raskaros Thomas. We are guided by Ms. Rensi Mary Murky and Ms. Agija Lakshmi. And coming to our current slides, it consists of objective applications, literature review, target users, need identification, target requirement, target specification, design, use case diagram, sequence diagram, the requirements, work done, bill of materials, achievements, and references. And coming to our objectives, a wearable hand tracker for CAD modeling serves to revolutionize user interactions, offering seamless hand-free control over 3D models, thereby enhancing precision, efficiency, and overall user experiences within CAD workflows. And our mission is to accurately and precisely interpret hand movements into meaningful gestures, creating seamless interaction between humans and machines. And coming to sub-objectives, it is to make a highly rigid response system to the input given using required hardware, and cost-efficient design, ergonomic design in concern of long usage time, and customization options for users using external software. And coming to our applications, it consists of 3D modeling, sculpting, texture painting, 3D requirement, environment manipulation, VR and AR control, several HMI applications. And that's about our application. Coming to our literature review, we have researched on many papers and we have come to conclusion about 4 papers that are gyroscope-based continuous human hand gesture recognition for multimodal wearable input device for human-machine interaction, and keyboard mouse glove with Bluetooth capabilities for the physically impaired, then self-calibrated multi-sensor wearable for hand tracking and modeling, and then design and development of a multi-control gesture recognition based robotic arm. And about the author and results have been discussed.
Move to target users, graphic designers and engineers, VR and AR interference users, basic human machine interface. Move to target requirements. Considering the information gained from survey, literature study, and need analysis, we have found out the following target requirements: precision, intuitive justice, compatibility, comfort, portability, affordable pricing, long battery life, customization, low latency, durability. It is based on the survey and literature study. We have found out the target specifications. Then move to need identification, combining details from user expectation survey and development information from literature review and other resources. We have formulated to a need matrix.
So next about the block diagram and working of our wearable hand tracker for CAD modeling. So we use two hand wearables on our both hands. On our left hand we use our slave remote device, and on our right hand we use our master remote device. Our master remote device consists of indicator LEDs, ESP32, NPU 6050 battery, recharge circuit, and 4 capacitive pins. The communication between master remote device and personal computer is done using Bluetooth low energy. So next is the block diagram of slave remote device. It consists of indicator LEDs, ESP32, recharging circuit, battery, capacity touch pins, capacity touch pins, and the communication between slave remote device and master remote device is using Bluetooth Classic. So next is the flow diagram. The left portion shows the flow diagram of slave device, and the right portion shows the flow diagram of master device. The functions of slave device consist of connect the slave device to the master device, read data from touch sensors, and send touch data to the master device. So in the functions of master device includes connect the master device to the personal computer, read data from inertial measurement unit, process the data from IMU, read touch data from slave device, read data from the touch sensors, and send the process signal to personal computer according to the sensor data.
Now we will see the basic core algorithm behind the working of the wearable hand tracker device. So we have already discussed in the block diagram. The system consists of an inertial measurement unit which has a 3-axis accelerometer and 3-axis gyroscope embedded in it. Our device uses both the sensor data from the accelerometer and gyroscope to detect the motion and acceleration of the device. As we all know, there exists a 9.8 meter per second or 1g acceleration acting perpendicular to the ground and downwards, and this force can be used to detect the current orientation of the device using the accelerometer sensor. So to get the orientation, we compare the values in the accelerometer axis, and the one with the highest absolute value is considered as the perpendicular axis to the ground. The values from the gyroscope axis is mapped into the imaginary tracking axis according to the orientation of the device, which we get from the accelerometer axis. So this is how the basic motion tracking system works in the device. And coming on to the circuit diagram, to the left we have the circuit diagram of the master device, and to the right the circuit diagram of the slave device. The master device circuit diagram consists of an ESP Room32 chip with an MPU6050 IME unit and a TP4056 charging controller unit connected to the 3.7 volt LiPo battery. The slave device also has a similar circuit and lacks only an MPU6050 IME unit with respect to the master device. And coming on to the expected output visualization of the wearable device, the design is built in the Blender 3.6 and rendered in Cycles X rendering engine. The basic structure are labeled, that is the enclosure with the electronic system and the power source, the strap support for uh, making the device wearable, and the rings with touch sensitive end portions. And coming on to the casing design, this is the casing design which we have done for our project. It is designed in Fusion 360 software for the purpose of 3D printing. Coming on to the use case diagram, the main users are the CAD modeler or the device user itself, the serviceman, the PC with the CAD software installed. Here the CAD modeler and the serviceman are the users of both right and left hand wearable device. The PC with the CAD software is the user of the right or master wearable device only. Coming on to the sequence of the input and the process in the system, the main actors in the system are the user hand and the PC. The motion is given to the inertial measurement unit, which is given to the microcontroller as the motion data. The touch data is given to the master microcontroller and the slave microcontroller through the inbuilt touch capacity pinouts. The touch data from the slave microcontroller is transferred to the master microcontroller, and the master microcontroller sends appropriate control signals to the PC according to the incoming data. This sequence is repeated in every iteration to achieve complete working of the system.
So next on the hardware components of our wearable device, and the hardware components consist of ESP32. ESP32 is the central process unit of our wearable device. The voltage rating is around 3.3 volt and current rating around 250 milliampere. Next, NV6050. It is a 3-axis accelerometer and 3-axis gyroscope. The power supply is around 3 to 5 volt, and the communication is based on I2C protocol. And next, TP4056, it is a low cost lithium ion battery charger controller IC, and the VCC around 5 to 8 volt. Next, LiPo battery, the voltage is around 3.7 volt and 400 mAh. Next, slide switch, the maximum voltage around 24 volt and the maximum current around 500 milliampere.
Move to software components. Arduino IDE. It is a software application used for programming and uploading code. Then Blender. Blender is a powerful open source 3D computer graphics software used for creating animated films, visual effects, ads, 3D printed models, and video games. Then ECEDA. ECEDA is a free and easy to use online tool for PCB design, circuit simulation, and schematic capture. Fusion 360 is a commercial computer aided design, computer aided manufacturing, computer aided design engineering, and printing circuit board design software applications. And Creality. Creality is a self developed FDM software produced by Creality.
To a breadboard level setup, our system consists of two main parts. One is about the master and the other one is slave. One consists of 4 touch pins and together about 8 touch pins. And the possible number of input combinations are about 20. And the communication between master and slave is through Bluetooth Classic. And the communication between master and PC is through Bluetooth Low Energy. And the next is about our standalone circuit in casing. And then a final product. And this is our bill of materials and their achievements. Thank you all.